Alright, in this video we're going to explore decision analysis using decision trees. Now a lot of you may be thinking, shoot, I know how to use decision trees. We used them back with conditional probability, Bayes' theorem. They were super helpful, but not super complicated. Well, true enough. In a lot of problems you can just sort of sketch out a quick decision tree, no problem. But with decision analysis, a lot of these problems get really gnarly. You can get an extremely complicated decision analysis problem where a tree is appropriate, but we need to get a little bit more scientific around the creation of our trees. We really got to set up our operations so we know and get organized about building these trees, because when you're looking at a really complicated decision analysis problem, it helps to have a very organized system for creating your tree. So let's go ahead and jump right into a problem. Here's the problem. A mining company is considering bidding on the rights to mine attractive land. If they choose to bid, they can make a high bid of $3 million, a medium bid of $2 million, or a low bid of $1 million. Okay? So far so good. If they bid high, the company has a 95% chance to win the rights. If they submit a medium bid, their chance falls to 50%, and with a low bid, they stand only a 20% chance of winning the rights. The yield from the land being bid upon is uncertain. A good yield, which has a 20% probability, would allow the mining company to generate $10 million in revenues. A poor yield is more likely at 30% probability, but it would only result in revenues of $2 million, and most likely is that the land will have no yield at all, which is a 50% chance. Okay. So we can see that this is sort of a complicated setup. And believe me, it gets a lot more complicated than this. Well, not this problem, don't worry. But what I mean is decision analysis problems. But this question is asking, all right, there's attractive land. We can have three choices in terms of how to bid. Then we might or might not win the bid. And then if we do win the bid, there's a different probabilities associated with the payoff, basically. So the question here is, A, should the company bid on the rights to the land? If so, how much should they bid? That's really the only decision point in this setup, in this question, but we have a number of factors to consider. Okay, let's talk about how to solve this. You can probably see right off the bat that a decision tree would make sense. I'm going to show you my rules for decision trees, and they're going to get, well, first of all, I know the handwriting's terrible, but also it's going to get a little bit complicated. You may not sort of follow with me, but we're going to work this out in solving the problem, so bear with me as I go through this. All right, here's my decision tree steps, and like I said, the handwriting's terrible. First thing we're going to do is we're going to build the decision tree from left to right, sort of from this first part, almost chronological order, from left to right. And we're going to use squares every time there's a decision, and then the branches off for the various decisions. And we're going to use circles whenever there's a chance. I'll call them chance nodes. And then we're going to have prongs and probabilities associated with each of those chances. After we've built out the decision tree, then we're going to start putting in values and probabilities. And we're going to do that from right to left. So going backwards. And that's going to make the whole thing a whole lot easier. You just have to trust me on that. We're going to, I'm going to run through this kind of quick because we're going to do it in the example. You're going to put probabilities and values above the chance lines. So every time there's a chance node, we're going to put the probabilities and the values associated with each of those chances above each of the lines branching off. We're going to multiply the probabilities times the values and put them below the chance lines. This is just the way I do it. Lots of people have different approaches. And then we're going to take the products from the chance lines. We're going to add them all up, depending on how many prongs we have coming off that chance line. We're going to add up all when we multiply the chance times the value, we're going to add those up, and we're going to put the sum above the chance node. That's sort of the value associated with getting to that chance node. And we're going to also draw paths from each of the decisions nodes according to the optimal value. If there's a chance node after the decision node, we're going to go towards the highest value decision, or highest value chance, from our decision node, and then we're going to take whatever optimal value that we had there, and we're going to put it above our decision node. All right, not all of this is necessarily in order. You can sort of play around with the ordering here, but these are our basic rules to follow. So let's use these rules and try to solve this question. All right, first off, so we're trying to figure out what should the mining company do. And I'm just going to refresh you with some of the information from the question. So first off, we have to make a bid, and we have really actually, I'll say we have three possibilities for bidding. We have a high bid, we have a medium bid, and a low bid. And then there's also this other possibility, which is no bid. No bid at all. And a high bid will cost us $3 million. That just says dollars million. Not what I was going for. See, I'm writing with this little, now I've got like my small pen set up here so that I can make this big decision tree and not write too big, but it's actually making my handwriting just that much worse, and it really didn't need any help. So we have a medium bid costs us $2 million, and a low bid costs $1 million, and of course, no bid costs $0. And then if we also have a chance of winning associated with each of these bids. That just makes sense. 0% chance of winning if we have no bid at all. With a low bid, we have a 20% chance of winning. Medium bid, it was a 50% chance of winning. And a high bid gave us a 95% chance of winning. So really good. All right, there's another aspect to this as well. We have the probability of, if we win the bid, the probability of sort of the yield from the land. So we have good has a 20% chance. I'll probably use 0.2 when we get to the case. And that gives us $10 million. We have a possibility of a poor yield, which is 30%. And that gives us a payoff of $2 million. And then we have no yield, which is a 50% chance and no dollars. You have any guesses right off the bat? You know, how we should bid based on all these values and probabilities? I don't know. If you do and it's an accurate guess, you're better at this than I am, because I have no idea. This is complicated enough that I would have to build a decision tree to really have any clue here. And actually, you'll see when we work this thing out, well, you can test your guess, but they can get decision analysis problems can get even more complicated than this, and already I'd be lost without some way of organizing my thinking. So let's start off. First thing we're going to do is we're going to build the decision tree from left to right, and we're going to put squares when we have a decision, and we're going to put circles when we have a chance node. So first thing is we have a decision to make. We're going to bid. We can bid high, medium, and low. I'll actually we'll write high bid, medium bid, low bid. And is that it? No, there's one more possibility, which is no bid. No bid. All right. And these don't have any probabilities associated with them. They're going to have a path associated with them. There's going to be an optimal decision that we make here. So we'll hold off on putting. There's no values that get associated here. So then after we've made our bid, there's a chance node. And the chance says, did you win the bid or not, right? Give myself a little bit more room. So we win or we lose. Win or lose. I'm going to hold off on putting probabilities in there. I know what the probabilities are. They're listed up here. But let's just keep building our tree out. All right? Now, if we win the bid, we have three possibilities. It can be a good yield, a poor yield, or no yield. It's always true, no matter what our bid was. Good, poor, no. Well, you notice I skipped over losing the bid? That's because, if we lose the bid, we don't really care. No money's changing hands. We didn't win the bid, so somebody else is paying for the land and getting whatever revenue may be associated with mining that land. It's not on us. So I'm leaving that off. We don't have to figure out what yield the land had if we lost the bid. So I'm skipping over those. because they don't matter. Not for our purposes, anyhow. All right, this is the decision tree. So I've got a tree here. It works. But we need to start associating values to this thing. So like I said, I'm going to start from right and move left. So first off, what is the value associated with a good yield on that land if I had a high bid, right? That's where I'm at here. I submitted a high bid, we won the bid, had a good yield on the land. Well, good yield is worth $10 million, and the bid to submit a high bid is going to cost us 3, so we're left with 7. And forgive me, I'm not going to put in the millions and the dollars just because I want this thing to go relatively fast. It'll still take a while, believe me. All right, a poor yield is only $2 million, but we still would have to. We're still at the high bid branch of the tree, right? So it's still that's going to cost us 3. So we'd only, if it has a poor yield, we'd actually end up losing money, and no yield at all, we'd also end up losing money. I'm just going to keep on going this route. Now, if we submitted a medium bid, that means we're only spending $2 million, but everything else associated with the yields are the same. So 10 minus 2 is 8. 2 minus 2 is 0. 0 minus 2 is negative 2. Pretty good at this math stuff. All right, down here, still 10 million. In fact, let's just do it like this. With a low bid, it's going to be just $1 million for that low bid. And one other thing down here, the no bid, that's a straight result of 0. If we choose a no bid, nothing's happening. All right, so now we have probabilities associated with each of these outcomes if we win the bid. Doesn't matter what we bid, the probability of the land yielding something is all going to be the same. So I'm going to fill those in real quick. This is 0.2, this is 0.3, 0.5, 0.2, 0.3, 0.5. Some of you will be able to deliver a neater, tidier decision tree. I'm just not capable. All right, let's keep going. I can already see I'm going to have space issues. It's going to be bad, but bear with me. Okay, now we can actually start. So you'll remember from my last slide, I said put the probabilities and values above the chance lines. Now, actually, in the interest of space, I put the values over here since we were all the way at the edge of the decision tree. I just put them off to the right, but you could put them above if you could fit them on also. But now the next step is to put their products below the chance line. So that's what I'm going to do. Also, I swear when I did this on paper, I had more room. I just, writing with this electronic thing doesn't work as well. Okay, so I'm going to multiply these out. 0.2 times 7 is equal to 1.4. 0.3 times negative 1 is going to be equal to negative 0.3. And you might not be able to tell, but that says 0.5 times negative 3 is going to be equal to negative 1.5. All right, now we can add these up. We have 1.4. That was my next step, if you'll remember. Add the products from the chance lines and put the sums above the chance nodes. So we can get a value associated with this chance node right here. Meaning, once we hit that point, based on all the probabilities and all the values, this is what our expected value is at that point. So we have 1.4 plus negative 0.3, well, I'll say minus 1.5 is going to be equal to negative 0.4. All right, let's keep working through this. 0.2 times 8 is going to equal 1.6. 0.3 times 0 is 0. 0.5 times negative 2 is negative 1. So this adds up to 0.6. 9 times 0.2 is going to be equal to 1.8. 0.3 times 1 is going to be equal to 0.3. 0.5 times negative 1 is negative 0.5. All right, add those up, and we get 1.6. So this is the value if we get to each of these points. Now we can keep moving to the left. So we have these probabilities of winning a bid, and these vary depending on what kind of bid we submitted. So here we have 0.95 to win on a high bid and 0.05 to lose on a high bid. On a medium bid, we have 0.5 and 0.5. By the way, how am I getting the losing number? I'm just doing the complements. You knew that. And a low bid has only a 20% chance of winning, therefore an 80% chance of losing. Now, the values associated with losing bids. If you lose the bid, it's a 0, right? I can do that. In fact, and since we're always multiplying by 0, values underneath are always going to be 0 as well. If I multiply them together, I might have skipped that step, but now so what we really need to figure out, we're going to do the exact same process, and we're going to figure out, we're going to multiply the value times the probability of getting that value, add those up. We know on the losing branch it's just going to be 0 each time, and get a new value associated with each node. So 0.95 times 0.4 is going to be equal to negative 0.38. I think. Yeah. Add that to 0, and we get negative 0.38. 0.6 times 0.5 is going to be equal to 0.3. Add that to 0, and we get 0.3. 1.6 times 0.2 is going to be equal to 0.32. Sorry, I should be writing these down below the lines as well, just to be consistent. And so, okay, the value associated with getting to this point is negative 0.38. Here it's 0.3, 0.32. Now, since we're at a decision node next, as we move from right to left, that means we can choose the optimal decision. And it's basically what we're seeing here is the dollar value, remember we're talking in millions, associated with each of these decisions. And which one is the highest? This one. I didn't actually mean to cover up my 0.32, but I did. So I can cross off these other suboptimal routes. I'm always going to choose to make a low bid because that one is associated with the highest value. So now I'll actually write in my full dollar sign, my millions. Oh, forgot to cross this one out. We're obviously not going to do a no bid because that gives us a value of 0. So this is our highest value. Let's go back to the question itself. Should the company bid on the rights to the land? Yes. If so, how much? $1 million, because that is a low bid and that has the highest value associated with it. What is the opportunity to bid worth? Well, looking at this, the value associated with a low bid is $320,000, 0.232 million. $320,000. Essentially, you'd be willing to pay up to $320,000 for the opportunity to bid. If you can pay less than that for the opportunity to bid, well, you stand an expected value that is positive, so you'd be willing to do that. Anything up to, and possibly including, you'd be neutral at exactly $320,000. Okay, these next questions make the decision tree a little bit hairier, so we're going to address those in the next video.